structure analysis, binary morphology, and their game morphology. What is edge detection? Edge detection is nothing but uh, how we are going to give the machine images and how the machine can detect the images during the edges and how we can detect the edge problem and how we can solve the edge detection problem. And simply it is a fundamental technique in an image acquisition, image processing to identify the location and sharp, discontinuous or abrupt changes in the brightness of the image. These discontinuous usually represent the most important features of the boundaries of an image what we are giving as an input. Where the pixel intensity changes significantly, the primary goal of the edge detection should be improved and the image quality should be improved. And what are the types of the edge detections? It is majorly it is classified of four types: Sobel operator, Prewitt operator, Canny edge operator, and the Laplacian Gaussian operator. The different types of operator responds what kind of edge detection technique is using and how we are eradicating the edge detection problem and how we are enhancing the pixel rate output. The Sobel operator is simply calculates the gradient magnitude of the image intensity at each pixel. Typically, we are using a convolution mask to detect the horizontal edges as well as the vertical edges, in which by detecting these horizontal edges and the vertical edges along a specific direction, it is relatively simple to implement and eradicate the pixel rate and also improve the edge gradient. And the Prewitt operator, similar to the Sobel, it uses the gradient based method with a different kernel structure. It is best for detecting the edge in the images with less filter and the great noise with a faster algorithm to eradicate the major problem. And the Canny edge detector is a multi-stage algorithm in which the higher accuracy rate and the ability to detect a wide range of the edges. It majorly involves the steps of noise reduction using Gaussian filters and the intensity gradient to suppress the intensity gradients by tracking the hysteresis, and also it produces thin and confused edges, making it one of the most reliable technique in the image acquisition system. And what is the Laplace? This is the first method which smoothens the image with a Gaussian filter and also to reduce the noise. Noise is nothing but an foreign object in which it will eradicate the, it will make the images to disrupting. The Laplacian operator is used to detect the regions of the rapid intensity change. It is the technique which is useful for highlighting the edges where intensity changes in both horizontal and vertical directions simultaneously. It is based on the second order derivative and it can be finer in details. Followed by their applications. The major applications of the edge detection is nothing but the object recognition and the face detection and the medical imaging. In medical imaging, the major application is the X-rays, CT scans and MRIs, where a small error can lead to a huge loss. So the edge detection is much more important in the medical imaging, where it is used in the fields of radiology and pathology. And face detection such as eyes, nose and legs are distinguished using edge maps. This is the widely used in biometric system, facial recognition software and smartphone face unlocking system. And the object recognition is identifying an object within the image by outlining their boundaries, and also it enables the algorithm to classify and interpret various shapes in a scene. And what is the texture analysis? It is an image refers to the spatial arrangement of a pixel intensities. For example, we are taking a image in a smartphone. The image in a smartphone is categorized into numerous pixels. That is nothing but in a normal image we can able to rectify, we can able to get how many pixel rate in an image, normal image. For example, we can take it as 1000 cross 480. That pixel rate is how we are intensifying it and how we are differentiating from the light color and the dark colors over a distributed area of region. Unlike in the edges, the texture deals with the surface properties of the image what we are giving, such as the roughness, randomness and smoothness. It involves in the extracting the meaningful features of patterns from this arrangement to help describe the appearance of surfaces of an image, followed by the types. The types is of three features. The types of texture analysis is classified into three features, nothing but the structural features, model based features, and the transform based features. uh, the transform based feature works in the frequency domain rather than in the spatial domain. Techniques like the Fourier transform analyzing the texture by examining the frequency component with the, while the Gabor filters and wavelet transform help identify texture information at multiple scales and the orientations. And the model based features, it involves a common approach of Markov random field, which assumes that the intensity of the pixel is influenced by the neighboring pixel. It's nothing but if a particular pixel is influenced by the neighboring pixels, it also get some disturbance that can be rectified by using the uh, Markov random field technique. So these models are especially useful for generating and synthesizing the texture as well as the complex textures of that image what we are giving. And the structural features is nothing but basic elements of combinations of such as dots, lines or regular patterns, and they described by the arrangement of the elements what we are seeing in the pixels, followed by their applications. Their application is nothing but majorly we are using the texture analysis in surface inspections and remote sensing and the biometrics. And biometrics is simply we are texture analysis individual based fingerprint and the palm print. There is the fingerprint and the palm print will be vary from persons to person, so we are using the biometrics for an individual persons. And the remote sensing is simply for satellite and aerial imagery relying on texture to classify the land types such as forest, urban areas, water bodies or agriculture. Simply we can able to segregate what kind of areas we are going to focus, like sea areas or desert areas or a city area or an urban area. We can able to rectify using this texture analysis. And in the surface inspection, like in mechanical field, we are able to compare with the quality using this technique to increase the efficiency and also the quality of the output product what we are getting while machining, after machining. Thank you. In next class we are going to see about the binary morphology and gray morphology. Thank you.